Hello, Hubble Huggers, and welcome to another Hubble Hangout. And this one, I'm really excited about this one because this is one of the first ones I've been doing. I'm actually doing this as the Hubble Space Telescope. It's funny because I don't feel like one. I don't feel any different. But you know, it says that I am the Hubble Space Telescope now, and so I'm here broadcasting as the Hubble Space Telescope. You also see me here, but as a member of the chat, but I've just got the Hubble Hangout banner on there. So let me just show you that because that's really awesome. That was done by Christine Godfrey here at the Institute, and I think it's an awesome graphic. So I just wanted to put that up there real quick. So before I get started with introductions, let me tell you how you can interact with the Hubble Space Telescope. That is me. What you do is you can comment on the Google Plus event page if you want to, and that's you may be watching this event here. In fact, I should probably type refresh your browser on the event page. Also, you can leave comments on the YouTube channel if you happen to be on HubbleSite channel, where we are also broadcasting. You can leave your comments there. You can also tweet. Oh, we didn't do a hashtag.
Hubble Hangout.
Hubble Hangouts. That's awful long. You're going to use up a lot of your characters, but if you use a hashtag Hubble Hangout, we'll see that as well. So leave questions and comments. We'll have plenty of time for that, hopefully toward the end, where we'll try to get to all that, unless I see a particularly interesting one in the middle, and we'll just blurt it out somewhere along the line. We'll be able to do that. So, new format slightly. With me also, as he always is Dr. Alberto Conti. Hello, Alberto.
Hey, Tony. How are you? Nice to be here.
Yeah, thank you. He's the James Webb Space Telescope Innovation Scientist. So, Alberto, what's new with the Webb? Are we still on track for 2018?
We are on track for 2018. We're making quite a bit of progress in testing. We have two of the instruments at Goddard Space Flight Center that are being tested right now and waiting to be integrated. There's a lot of a lot of time is going to be spent into doing testing for the next few years. So it's a very exciting time, and so far we're doing very well. So nothing major to report, either negative or positive. We're just doing very, very well. We're on track. We're very excited, and we're working hard to make sure we stick to that deadline.
Awesome. I mean, they're building all that right down the road, aren't they, down at Goddard?
Yeah, it's just around the road. It's a few miles from here, a few kilometers if you're in the oil country.
Oh, there you go. Metric for the win.
Yeah. Oh, good. I mean, 2018 can't come soon enough for me, so I can't wait. I'm glad to hear it. Okay, thanks for the update. And also, brand new addition, Scott Lewis from KnowTheCosmos.com. He is, you recognize him probably as the co-host for the Virtual Star Party with Fraser Kane. He also inexplicably goes with the Twitter handle, the Bald Astronomer. I'm not quite sure what that's about. It must be.
It's a long story. It's a very long story. Yeah.
Anyway, welcome, Scott. It's a real pleasure to have you with these Hangouts. I'm looking forward to working with you on these, and you're an awesome person in these things. So thanks for coming.
Hey, I've tried to emulate you as much as possible. I think it's working.
I find that almost always serves me well.
Yeah. You know, if you weren't so humble, you wouldn't be perfect.
All right. I'm getting fed just by listening.
Okay. So now, as you all know from the title of the Hangout, we are here to talk about comets, and in particular, Comet ISON. And I would like to introduce some planetary scientists we have with us today, two of which work at the Space Telescope Science Institute, and the other one at the Planetary Science Institute. So why don't we start with Bonnie Meinke. Hi, Bonnie.
Hi.
Hi. So why don't you introduce yourself? Tell us what you're doing.
Sure. I'm a planetary scientist, but I'm also a content specialist at the Space Telescope Science Institute in the Office of Public Outreach. And what I've mostly studied my whole career is Saturn, but I had one project back when I was an undergrad in college where I studied the possibility of interstellar comets. So
awesome.
That's my background in cometry.
And cometry. Oh, that's a great
cometry.
Wow.
Hashtag.
Yeah, cometry. I like that.
But we don't need trees on comets, right?
Okay, and also with me, Max Muchler also from the Space Telescope Science Institute. Max. Oh, you're muted.
It's muted.
Sorry, unmuted. So my name is Max Muchler. I'm a research and instrument scientist here at the Space Telescope Science Institute. I've actually been here working on the entire Hubble mission, 23 years. And I'm an expert on Hubble's cameras, so I really know how to design observations and reduce the data that comes out of it. And I also am a member of the Hubble Heritage team that is doing some of the observations of Comet ISON, the one that was released yesterday and one that was released earlier, and we have more observations coming up. So I've been involved with a lot of planetary science with the Hubble Space Telescope, earlier comet observations, including ones that have broken up, and observations of asteroids and dwarf planets like Ceres and Pluto. And so excited to be a part of this, these Comet ISON observations, and look forward to a lot more coming forward.
Awesome. Yeah, well, welcome. That's good to have you here, Max. And also with us is Dr. Zhanyang Li from the Planetary Science Institute. Welcome. Can you why don't you introduce yourself?
Sure. Hello. Hi, Tony. Glad to be here.
Yeah.
And my name is Zhanyang Li, and I'm a research scientist at Planetary Science Institute. And I mostly work on almost all the solar system small bodies where we have data, of course. And I actually started as a cometary scientist at University of Maryland, and with Dr. Mike Ahern. And if you don't know the name, that's fine. But I think you must know the mission, Deep Impact mission. And Mike Ahern was.
Oh wow! Yeah.
Yeah. So that's how I started my work on comets.
Awesome.
And then right now I'm also working on asteroid missions. Like I also participated in Dawn mission as a science team member. And I also worked on the Dixie mission, which is the extended mission of Deep Impact, and also Stardust Next, which was the extended mission of Stardust mission. And and that's what I do right now. Yeah, I'm gonna talk more about Comet ISON.
Well, welcome. It's awesome to meet you. I'm looking forward to finding out more about comets from you. And also with us is Zolt LeVay. He's been on these Hangouts many times before with other things, but he is a imaging. He's the one that takes the images that Max has provided and turns them into amazing-looking images. Welcome, Zolt.
Thanks, everybody, and glad to see everybody here. Yeah, I'm in the Office of Public Outreach here, imaging group lead in the Office of Public Outreach, and I'm also the lead of the Hubble Heritage team. Max was talking about Hubble Heritage. And some of the observations that we'll be talking about were conducted for Hubble Heritage.
Okay, so before we get into the discussion too much, I want to start right off the bat by introducing, one of the reasons we're here is we want to introduce the ISON blog that we've started at the Institute on HubbleSite.org. I have it up on the page now. On the very top of the blog is an image that Zolt helped create, which we'll talk about more in this. But there are all kinds of posts on here all about not just Comet ISON, but comets in general. So we're hoping that you will subscribe to the RSS feed on this and see the posts. Some things that are imminent is I've got a video coming up on whether or not Comet ISON will actually hit us. That's going to go on the HubbleSite channel, YouTube channel, and we'll post it on this blog. So look for that in the next, hopefully the next day or so. But the URL for this is, unfortunately, I can't get my lower thirds to work because I'm doing this as a Google Plus page, and I had all kind of permission problems. So hopefully you can see the URL up there, but I will also be posting it on the event page. It's hubblesite.org/go/ISON, and that will get you there to check it out. So please subscribe to it and follow it, and leave comments and do what you can and interact with us on this. Okay, guys. So comets and Comet ISON. Hubble is going to observe this. Now, is this a new thing? Is this one of the first comets that Hubble has ever observed, or has it done this before? Who wants to go? Max?
Go, Max.
Go, Max.
Again.
Yeah, I'll take that one. No, Hubble's done a lot of comet observations. I've been involved in quite a few of them. So I would say, going back to the very beginning, probably the most famous one early on was shortly after Hubble was repaired in 1993, late 1993. Couldn't have been scripted any better. We had a comet, Shoemaker-Levy 9, that broke up due to a close interaction with Jupiter, broke up into a string of comets, which then slammed into Jupiter just about 6 months after Hubble was repaired. So it was just a beautiful, obviously a fantastic, never-before-seen astronomical event of a comet breaking up and slamming into Jupiter. But then you have a recently repaired Hubble just primed to actually observe it the way we can, with the full resolution sensitivity that Hubble offers. So that's certainly the earliest, most memorable one, but since then there's just been countless comet observations. I've been involved with, there was one a few years ago called Schwassmann-Wachmann 3, which broke up similarly into a string of pearls and was just one of the most stunning breakups of a comet ever seen. And also Comet Holmes, which was just a ridiculously bright eruption of a comet, and a whole bunch that I'm sure I can't think of. I think John Yang Lee can probably remember a few more, and certainly we expect to have many more going forward.
So Hubble's been pretty active then in looking at comets. Now the other one, the SW3 one, I don't pronounce it the long way because I don't want to even try. But that one's actually going to be in the longer version of the video that I'm making, where I talk about that string of pearls you were talking about. Alberto, you just had that image of
actually, that was Shoemaker-Levy 9,
yeah.
and it was observation of, you remember that probably Shoemaker-Levy 9 was very, very interesting, at least I remember very, very clearly, because it's actually smashed into something, which is Jupiter, which is fortunate for us. It's very fortunate for us, because it's like a giant vacuum cleaner that helps us not being wiped out of the face of the planet. But yeah, this was observations of the scars, if you will, that Hubble observed at the southern part of Jupiter has Comet Shoemaker-Levy hit. I thought it was an astonishing. But Max is right. I mean, Hubble has been at this for many, many years, and there are quite a few. I don't know them all. Maybe others can intervene.
Actually, you brought up a really good point that I'd like Bonnie to comment on for just a second. Jupiter acts as a kind of solar system vacuum cleaner or some sort. Can you expand on that just a little bit? Because that's an interesting point, I think. Jupiter actually protects us quite a bit, doesn't it?
Yeah, it's this gatekeeper to the inner solar system because it's so massive.
So how does it do it? I mean, what is it? Is it just because it has a gravitational field that keeps things diverted, or it just happens to draw things into itself so that it gets smashed into it instead of other planets?
Yeah, basically. It grabs things gravitationally, diverts them off their original course, and sometimes those things, change their overall orbits, come back around and hit Jupiter itself, or sometimes they're captured into these little communities of asteroids that flank Jupiter in its orbit. And sometimes they're tossed way the heck out of the solar system altogether. Wow. So it does a good job of protecting what's inside of the orbit. So that's all of the terrestrial planets.
I wonder how big of how likely it would have been we would have survived had Jupiter not been there. I never really thought of it like that before, so I think it's pretty cool.
So maybe calling it a vacuum cleaner is not actually very, very nice. You should call it something of the savior or some sort.
Jupiter the savior? I don't think I want to go there.
No, but it has a stabilizing effects on sort of who gets hammered by comets or something, which is
it's
actually
our Jovian big brother protecting us out in the, the playground out there.
There you go.
Yeah, keeping all the bullies away from us.
That's right.
There you go. That's much better than savior. Yes.
Jovian big brother. Okay, so there you go, folks. A new role for Jupiter, our big brother, our really, really big brother. Okay, so with one of the interesting things about comets in general, and we'll get to Comet ISON in just a minute, that I think is an important topic is when we started tracking Comet ISON and we decided we were going to make this blog and we were going to do some articles and some topics on the blog, the first thing we do is we look, we did some Google searches to find out what other people were asking, and of course one of the big ones is Comet ISON going to hit us? Now I don't want to talk about that directly, but I want to talk about the more, at least not right now, because we'll get into it a little bit later. But right now I would like to address this issue of comets actually hitting a planet, especially one like Earth, is actually not a bad thing. I mean, because it can bring some important things for life on Earth here. At least that's the theory, right? Anybody care to comment on that?
Yeah, I can just add one comment, which is the way I always put it is that comets, and you could say asteroids as well, they giveth and they taketh away, right? It's a part of the story of how the Earth got its oceans. There's no reason to think the Earth had water early on, And I think a big scientific question, still an open question, is how Earth got its oceans. Comets clearly seem to probably play a role in that, but they don't seem to answer the entire question. And but so it might be that again what giveth life on Earth, right? We needed water on Earth to have life and to have us. And then of course you're familiar with the the event that caused the extinction of the dinosaurs. An asteroid or comet impact that can wipe out life. So depending on the timing, it can either giveth or taketh away. But either way, they clearly have a big role to play in the story of life on Earth.
Well, I think a great question about that too is what's the difference between a comet and say something like this that smashes into the Earth? So a meteorite coming down, they're different, and maybe people don't understand the difference between a meteor and a comet. Can we go into what the difference between them is and why they would do different things with an impact?
Sure. I mean, a meteor is a very small particle. I mean, most of the meteor streaks you see in the sky are probably like a dust fleck or maybe a piece of gravel. Obviously, the Russian meteorite was larger than that, but that was a pretty rare event. And quite often, what they are is the particles left over from a comet, kind of in the trail of a comet that we plow through. The reason they occur, the ones that occur on a regular date in the year, it's because a track. Think of it as like a horse that's been running around the same track and leaving a trail. And once a year we plow through that trail, and that we get a meteor shower. But again, those are very small particles, so not like like an entire comet or an entire asteroid.
Yeah, in fact, if I may, I'm sorry, if I may add something to what Max just said. For a lot of actually all the meteorites, they have to survive the atmosphere, passing the atmosphere. So they have to have some strength. They have to be strong enough. And those meteorites are mostly come from asteroids rather than comets. And those particles that jet off from comets, they mostly just stay very weak. I mean, by weak, I mean if you take a part of it and put it on the ground, it will collapse right away. So for that kind of strength, it's very hard for them to pass the Earth's atmosphere. Most of them just burned out when they pass the atmosphere, making the fireball that we see. And also right now we consider that a lot of meteor showers are actually caused by the bigger particles, like centimeter size or millimeter size particles are left out in the trail of comet, in the orbit of comet. And when Earth passes the orbit, comet's orbit, a lot of such gas will enter the atmosphere and make a meteor shower.
So those comets, are they the ones that were the short period, the ones that make return visits? We're going to get to the different kind of comets in a minute, but these are the comet. The meteor showers that we see, you say, were particles left over from some of the comets that have gone by. Do these tend to be the periodic comets that leave debris in certain spots in space, or are they all comets?
Well, potentially, all the comets have the ability to make meteor showers. As long as all the comets are losing particles in their orbits, and as long as Earth past their orbit, Earth's orbit and the comet's orbit cross, when Earth passes the orbit, there will be a chance to have a meteor shower. So Comet ISON actually, Earth will pass Comet ISON's orbit in January, and that will be another story. We might have some kind of meteor shower from ISON too.
Okay, so there's different kinds of comets. I alluded to this just a while ago. We have these comets that make return visits. They come around, and they're called shorter period comets. Then we also have long period comets. Bonnie, can you comment a little bit on the difference between those kinds of comets?
Short period comets tend to come from the Kuiper belt, which is that region of icy bodies just outside of Neptune's orbit. And so those come back on a regular basis. They come in, like periods of, say, under 200 years. So human history actually has a record of these things reoccurring. A good example is Halley's Comet that last appeared in 1986. So everyone, my little sister was born in 1986, everyone in her class was named Halley. So I imagine that might happen on comet years for these popular short period comets. Long period comets come from much farther out and are usually on a one-time trip through the inner solar system. So those things come from the Oort cloud, which is this huge outer sphere of icy debris that stretches as far as 50,000 times as far away from the sun as the Earth is.
So is that the right way to pronounce it? I always say Oort. Am I saying it wrong?
I've always said Oort just because it's easier, but
oh, okay. I turned that into 2 syllables. Is that okay? Is that proper, or is that wrong?
No, it's completely wrong.
Yeah,
I don't know. I'm just joking.
I did Oort, yeah, the Oort cloud.
Oort. Okay. Okay. So those are longer period. They tend to have these orbits that are parabolic or hyperbolic, and they only come through once generally, right? They wreak all kinds of mischief and then they leave. And that brings us to Comet ISON, right? That's what kind is it?
ISON is a long period comet.
So it came from the Oort cloud. Oort.
Yes.
Cloud.
So, but one thing, maybe it's important to actually notice that I think the Oort cloud is also a reservoir, as Bonnie mentioned, but it's a gigantic reservoir. I was reading numbers where they might counted the trillions of these objects just sitting out there, waiting to be disrupted gravitationally and then fall inside, in this very hyperbolic orbits, which I find actually mind-boggling.
Yeah, agreed. So. So let's talk. Okay, let me get Zolt in on this a little bit. So Zolt, you released an image of this comet. Actually, you released several. Why don't you talk about some of the images you put out of this comet that came from Hubble?
Sure. Let me.
I can show one.
We've released a few.
Oh, okay. Here's
okay,
Alberto's got one up. That's the latest one.
Okay, the latest one. Yeah, let me talk about that one first. Since it's the freshest, and it's. We're highlighting that, excuse me, on the blog right away. So let me share my screen. I've just got a few.
Well, I have it up already, Zolt.
Oh, you do?
Yeah, I have it up. It's already embiggened.
Okay. So this image, let me see here. So this image is actually a little different from ones we've done before for a couple of reasons. As you can see, it's in color. So we took images through different colored filters, 2 different colored filters, and composited them into a color composite image. So that's why you see some of the stars are bluish and some of the stars are reddish, and in fact you see other stuff in the background. You see galaxies and you see some stars. So it's a little bit different image from Hubble, at least, of a comet. You see the comet fairly small in a larger field of view with this background of stars and galaxies.
Yeah, that truly is a view that only Hubble can provide. I mean, that's amazing.
Well, at least of this comet right now. So, and the other unusual thing about this image was that we tracked not on the comet this time, but on the stars. And comets, as rapidly moving solar system objects, they move pretty fast across the sky in relative terms. And so even in a fairly short exposure of a few minutes, the comet actually trails across the field of view. So if you look closely, and in fact, if I do share my screen,
okay,
and show another slide here.
Okay, we're looking at it now.
Okay, so I will. So here's the image again.
Right.
But this slide shows all the images we took. So we actually took 5 separate exposures. So there are 3 exposures in one filter at the top. That was a visible light filter in the sort of yellow-green part of the spectrum. And on the bottom, there are 2 images that are.
Wait, we're not
red.
looking at that. All we can see is the second slide. We see the one
really?
that says April 30, 2013. Yeah. Are you doing a slideshow?
Yeah.
Yeah. Unfortunately, that doesn't tend to work. You now need to. There you go. Now we're looking at it.
Okay. Now you can see it. Okay.
Yeah.
I'll just show it like this.
Yeah.
So anyway, we took 5 images. The 3 images in V are at the top, and 2 images in red are at the bottom. And if you were to look closely at that, you might see that the comet was moving, but it's a little hard to see in the separate images. So in this image, however, maybe I can make this a little bit bigger.
There, that's real nice.
Okay, so these are these are all the images through each filter composited. So there are 3 images in the V filter, and as you can see, the comet looks kind of funny. It's actually got this sort of L-shaped little patch. The stars are nice and and pinpoint it because we were tracking on the stars. But while we were tracking through the 3 exposures, the comet moved a little bit. And like I said, this is not the way comets are usually observed. We want to actually have the comet be as stationary as possible, so we usually track on the comet. But in this case, we wanted to get this background of stars and galaxies fairly deep and show the comet in front of it. But the comet did move. However, with a little bit of, I won't say trickery exactly.
NASA trickery. I knew it.
A little bit of manipulation. We were able to, well, first of all, we applied color to the 2 images. So we applied a blue color to the V filter image and a red color to the I band or red image, and composited those together to make the color composite. So this is the original color composite. You can see that the comet is a little bit funky there. So
yeah, I can see the L shape now that I saw the other ones. Yeah.
But what we did was we actually replaced that comet image with one of the exposures where the comet was trailed the least.
Well, you just took all kinds of liberties here.
We didn't like fake it exactly. But you know, we try to make a nice looking image. So, and we cleaned it up a little bit. There's some retouching done. There's some artifacts from the chip gap and other things that we cleaned up a little bit. But
and that's something I think you bring up a good point. Let's talk about that just a little bit, because I don't think people appreciate, well, you know, maybe some people do, but there's this idea that these images just sort of come out of the telescope like this, and they really don't, do they, Max? I mean, they really don't, you know, have these real pristine sort of colors to them and everything else. The way they come out of the camera, or at least off the Hubble Space Telescope, is actually kind of messy, aren't they? I mean, that's one of the things you do, is you help kind of clean them up a little bit, right?
That's right. I mean, I could screen share as well here to show what the data looks like before it gets to Zolt's desk. So I'm going to switch here to screen share mode.
Okay.
So I might be able to show with a little bit higher resolution as well what Zolt was talking about. So this first image I'm showing you here is just one of the long visual band exposures, and I think you can see right there. You can see the comet tail looking about the same, but you can see the comet nucleus, instead of being a nice dot, is a little bright line at about a 45-degree angle.
And that's because it moved during the exposure, right?
That's right. So we took a long exposure. That's why we got, you know, you need a longer exposure in order to detect all those stars, and especially the galaxies in the background.
How long was it, do you know?
Yeah, this was something like 200 seconds, something like that.
Okay.
So that's how much the comet moves in that amount of time during this long exposure. And then if I go to the next one, so then you stop that exposure, you take another one, and you see the comet has moved. That's the next exposure. Then I'll click to see the next one, and you can see it's kind of turning a corner there in the L, and I'll explain that in a second. And the next one, and the next one. And if I go to the, let's see, here's sort of the L image that Zolt was showing.
Oh, wow.
All of them together. So the comet itself is moving in a linear fashion, and the reason it looks a little bent like that is because Hubble itself is moving as well. During one orbit, Hubble goes from one side of the Earth to the other, and so that's called parallax. You know, which you experience yourself with, you know, something that's close to you, and you move your head side to side. You know, the thing that's close to you moves more than something that's farther away, and so you get, you know, that sense of you know, perspective. So, you know, that weird motion you see there, it has more to do with the motion of Hubble than with the motion of the comet itself. Now, just to show you how messy the image is, to get back to your original point, I'll pull up the same version of this image. Now, this is after I've cleaned it up quite a bit. So now I'm going to switch to what that image looks like before I've cleaned it up. And what do you see here?
What a mess! So this is a raw image, right? This is what it comes out of Hubble.
Right. So, you know, we've been looking at cleaned up images, and it takes some effort. And this last one I'm showing you right now shows all the junk, you know, before I clean it out. So what are you seeing here? You got a mixture of the real stuff, the comet, the stars, the galaxies, but then you got all these big things, these bright things here, like this big bright one going right through the comet tail. And there's an even brighter one right up near the comet. Yeah. Those are called cosmic rays. And all these little flecks, too. It looks like salt and pepper has been shaken all over the image. You know, one of the reasons we put a telescope above the Earth's atmosphere is the Earth's atmosphere protects us from all that radiation out in space. Right. So it's great that, you know, life on Earth wouldn't be possible if the atmosphere wasn't protecting us, but of course, you get up above the atmosphere to get above the blurring effects of the atmosphere, and now you're exposed to that radiation. So while we're taking this 200-second exposure, all this radiation is flying right through the telescope and peppering every image with these cosmic rays that you see. And then, of course, there's also detector artifacts. No camera is perfect, so there's all kinds of, in a sense, junk coming from the camera itself that needs to be cleaned out.
Bad pixels, hot pixels, things like that, right?
Exactly, and so that's why we take many exposures, is to not only gather information in different wavelengths of light, as Zolt described, to make a color image. We have different filters, but we also, within a filter, take multiple exposures so that we can combine them. And by comparing the images to each other, if I take 3 or 4 images in a row that should be identical, the stars and the comet and the galaxies will all be in the exact same place, but the cosmic rays will be in random locations, so that you can compare the images and say anything that's in all the images must be real, and anything that's in random locations must be cosmic rays, and reject it, and that's how you get a clean image. So you can see we are contending with quite a bit here, and sometimes you're lucky in the sense that you really don't want a bright cosmic ray going right over the top of your image. It might be tough to clean out. You might notice in some of these images, I'm just going to click through to one. For the red exposures, we didn't take as many. We only took 2, and that makes it harder to clean up. And you'll notice right above the 2 comet trails here, there's a pretty bright cosmic ray that there's that really bright one. I couldn't get it completely cleaned out. So it's just sort of a cautionary tale that no astronomical images are perfect. There can be artifacts that hanging around that you might look at an image like this and get excited about and think, well, that's something to do with this comet, when in fact it's just a random cosmic ray that couldn't get cleaned all the way out.
Well, I was going to say it might have been a spaceship or something right behind it there. But
it's an important point to make, because we have been inviting, normally, historically, it's mostly professional scientists who've been getting into our archive, people who use Hubble getting into our archive, but we have been inviting the whole world in there to, have a look at our data. And of course, it just requires a few more skills in terms of understanding what you're seeing and interpreting data. And looking at raw data, as I pointed out in the last one, there's a lot of junk there. And the untrained eye might get excited about what they see, thinking that this long streak is something more exciting than just a cosmic ray. But and that's why we actually provided, I actually posted our cleaned up images. There's a link to it from the blog and also from the press release. So people who are interested in playing with the actual data in FITS format, if you don't know what FITS format is, you probably don't want to do that. But a lot of amateur astronomers, and including professional astronomers, are familiar with that. And so, kind of getting at the data behind the image, you can follow that link to actually get my version of the data, which took a lot of careful processing. Unfortunately, our routine pipeline doesn't do such a great job, so it really requires a lot of offline, tender loving care to get the image, cleaned up image like you see.
Okay, but don't give away too much of our punchline, because that whole topic is going to be another hangout that's coming a little bit later, either early next month, I think, or sometime next month. So we're going to be talking about getting Hubble ISON data the way Max is talking about right now, and just in a future hangout. So we definitely want you to stay tuned for that one. So okay, well, I gotta move on to something different here, because one of the things you can do when you're in a hangout with a bunch of other people is you can kind of see that there's this little chat window that you guys don't get to see, but that we do, and this is where everybody makes fun of everybody else when like they call me names, or I call Scott a name, or whatever. But there's actually a really cool conversation going on the side here, where Scott was reading one of the comments and the questions. And so can you guys kind of talk about what you're chatting about over here? Scott, go ahead.
Yeah, so the question posed was by Budini Samara Singer, and she's asking, what's the most dramatic example of terraforming that can be attributed to a comet, either Earth or another planet, within the solar system? Thanks.
Well, I think that terraforming in the sci-fi sense, where we go to another planet and make it like Earth, that really doesn't happen. But comets and all the other small bodies in the solar system are always terraforming, so to speak. They're always changing the surfaces of planets. So look at the moon, all those impact craters. Mars is full of impact craters, as is Mercury, and a lot of the icy satellites around the outer planets, Jupiter, Saturn, Neptune and Uranus, and so there's all kinds of examples of these impact craters.
And Zhang, you also had a comment on there. Why don't you say what you were typing in there as well?
Yeah, I was going to say a very similar thing as what Bonnie just said. Comets are basically too small to contribute any significant mass on any planets. Mostly comets are just a few kilometers in size. And the largest comet we know so far is Comet Hubble, which I think has a radius of 35 kilometers. And in comparison, the Earth has a radius of 6,400 kilometers. So that's huge. So in that sense, I don't think Comet will make significant contribution to make any lands on any planets.
Okay, but maybe they don't contribute a lot to the land, but the land area or actual real estate, but they do add a lot of chemistry, right? I mean, there's a lot of chemical contributions that they make. Do you have an idea of the percentage? I mean, we have a planet, it's forming, it's got an atmosphere. These comets are bombarding it. Let's say, I guess the early Earth had a pretty toxic atmosphere early on, and comets started hitting it. Is it a majority of an effect, or is it just a minute effect? What? Well, maybe it's impossible to predict. I don't know.
Well, we have to know that the Earth, the Earth's atmosphere is only a very, very small part of the Earth, total mass of the Earth. So in that sense, comets just need to contribute a tiny bit of organic or water to the Earth to make a very thin, we call that biosphere. So it's not measured in how much mass or how much percentage. It's measured by its importance. If there's no, probably right now we think probably it's just a comet or some kind of asteroids that delivered organics to the Earth or water that makes life. That's the importance. That doesn't matter how much it is.
So is it adding just more diversity of the chemistry to, the iron nickel planetoid that's forming there? It's just adding some additional chemistry that wasn't necessarily there because it was outside of the frost line when it's forming?
Yeah, I think most importantly maybe water, because very early on the Earth it's very hot, and there are volcanics everywhere. I think Bonnie may want to say something about this, but that kind of high temperature will drive out all the water, at least on the surface, near the surface of the Earth. And then later, when the Earth cool down and cool down to the current temperature or slightly higher than now, where it can retain water or liquid water or water vapor, at that time, some kind of comets or asteroid, other things impact the Earth and deliver the water. That's what we currently think about how water comes from, how water originates from the Earth.
All of it?
I don't know. It's hard to say.
That's a pretty big
concept. We know that the comets make it rain, huh?
Yeah.
That's what's going on?
Yeah. So Scott brought up a term, and he didn't define it. He said the frost line.
Yes.
Who wants to tell us what that is? Nobody?
Nobody.
I can tell you what it is.
I know we have
at least someone knows what it is. Woo! Our credibility is about to be wiped out there.
I was deferring.
You were being polite.
I'll cover it.
No. That's rule number one. Don't be polite. Just go.
Okay, I won't be polite.
Please be rude.
So the frost line is the line, the distance from the sun at which certain, I'm going to use another word, volatiles can exist.
Good. I'm glad you said that.
A volatile is, water is a volatile. There's a lot of other sorts of ices and things that are in the outer solar system that are considered volatiles. They're things that you add a little bit of energy to them and they evaporate or sublimate and go away. So they don't like to exist around heat. So when you're close enough to the sun, you're not going to be able to exist as a volatile. And that sets up the frost line. And in our solar system, the frost line is outside of where, I don't know exactly where the frost line lies in our solar system. It's somewhere around Mars-ish.
Okay.
It's actually around 3 AU, 2.5 AU to 3 AU, or 2.5 times the distance between the Earth and the Sun. And that's where Comet ISON is now.
It's right there at that frost line.
Yep. Comet ISON is working on crossing the frost line now.
And that's one of those important things. That's why we care about the frost line as it relates to comets, because we get this beautiful tail on a comet, and the coma, and all of that stuff starts to appear as the comet gets closer and closer to the sun, because these things are warming up and these volatiles are coming off of the nucleus itself and making the real structure of what we think of as a comet.
So
Awesome.
since ISON is
Show.
since ISON is now crossing the frost line, does it mean its tail is going to be a lot bigger and brighter now?
Well, that's what we all hope, right?
Yeah, that's what we all hope.
Yeah.
Exactly.
Although
Yeah,
we can't see it, unfortunately, right now.
It's not saying that Comet ISON was not active before it crosses the frost line. It's just saying that within the frost line, water will be sublimated much faster than it was before it crosses the frost line. And
Actually,
before that, was possibly volatiles that can sublimate at much lower temperature, likely, most likely the carbon dioxide or carbon monoxide. So that's what we think.
Okay, so so now that we're getting on to more, what do you got there, Alberto? You got stuff.
Well, I was distracted by the frost line, and that's why I didn't answer immediately. And so Bonnie did the right thing. But I was because I was thinking actually how much water is there on Earth compared to the entire mass of the Earth, and so the number is a fraction of a percent. And I remember there was a nice graph that showed actually if we took the entire water on Earth and made into a little sphere, how would it compare to the size of the Earth? And that's the graphic.
Oh, okay. So that big ball is the Earth, just the land. That little ball right next to it is if you took all the water off and made a ball out of it.
Yeah.
How big it would be.
Correct.
It's like one.
What's the little dot? Isn't
The little dot I think is from I don't know. I think is actually I think the big dot is actually salt water and the other dot is actually
Freshwater.
fresh
nice.
water.
Yeah.
Oh wow, that is a cool graphic.
So I remember seeing that a while, and so I thought. So.
Now we need a dot that shows how many people are on the planet and compare it with.
Yeah.
Make a ball of 7 billion people.
Yeah. That'll be the next hangout.
All 7 billion people will be on the hangout.
Yeah.
World record again.
Yeah,
We can
watch
find another
that,
world record.
Google Plus. That's right.
So, but actually, going back to what we were talking about Comet, being active and what Zolt was mentioning and Dr. Lee was saying. So, do we have any idea actually how bright? What are the models predicted for the brightness of the comet? There was I think Araya Baganpour that was asking, what are the estimates basically? Do we know? I mean, we don't know. Obviously, what are the estimates, right?
Well, you've heard estimates. You've heard estimates suggesting that it could be as bright as the full moon. I'm sure it's none of us are in the game of estimating the brightness, but I'm sure it's based on models and it's very speculative. It's a very risky prediction to make, I'm sure.
Oh, come on.
Now, here's the thing.
Yeah, nobody wants to say. Nobody wants to say.
No, but I guess my question is, I read as well, and it's like it goes from it's the brightest of the century is as bright as a full moon to we don't know, and so I understand there's uncertainty, right? But so we have more than one comet we looked at. What is our record? I guess that's the question I'm asking in being able to predict it.
Very bad.
Well, I think
Very bad. Okay. Okay. Well, that's good. That's good to know.
Yeah.
Well, I think I know the answer to what is the brightest comet ever seen on Earth, and it must be the one that killed the dinosaurs.
Yes, that was the comet of the century. There, anyway.
It just wasn't our century.
I'm guessing it was incredibly bright on the way in.
Yeah, for a short period of time. Yes. That's a good one, Max.
Well, all right. So, Max, you've done it. That's our segue into the topic. Will Comet ISON hit us? Who wants to predict?
Me? No.
Oh, Alberto's going
wow.
on a limb and saying no.
Spoiler alert from Alberto.
No.
Darn.
Okay, so
No, but I think we mentioned it before, right? Maybe the debris that left of the tail. Maybe we will go through some of those debris, and those debris will produce nice meteor showers. Who knows? Comets do produce that.
So I have this really cool animation that they came out with over at JPL. Can you guys see it?
Yep.
Yes.
Okay, so I'm gonna make sure I got it big so everybody can see. Let me get the right window. Yeah, there it is. Okay, so here's their prediction of where Comet ISON will go. I'm just gonna go play this. There's music associated with it, so I don't know if you can hear that or not. But
Nope.
here it comes. Okay, good. So
Make some music.
Yeah, sing to us, Tony.
Like the
Comet ISON going around right there, and here is where we're now in December 8th. And boom, right about, whoa, it didn't stop. It kept going.
Well, that's what comets do, Tony.
I know, but it didn't. My animation kept playing. What are you doing? Come back to me. Okay.
We don't
So
have a pause button on the comet.
I pushed the pause button and it didn't pause. So right about here, what is it? Well, I got to do this without. Oh, this is like really sad. Okay, right about here. That's December 19th. I can't get it right to January. There we go. December 25th. There's Christmas Day. That's one of the closest days that ISON will be. And look, see how far away it is? Many, many millions of kilometers away. So this is the closest the comet will get to us. So no, it will not hit us. However, there is a neat little thing that it will do that will happen to the Earth right here. Did you see that the Earth on January 17th is right on top of this trajectory where the comet had gone in earlier in the year? That is a path the comet has already taken, and Earth will pass through that. And so maybe, just maybe, there will be a nice little meteor shower somewhere in the middle of January 2014 from the particles left behind when ISON flew through before. So that is the little animation that I had for that.
Okay, I want to go back to the question though. Okay, will not hit us, but do we know? Do we at least know how? Maybe I asked this already. I don't know. Do we know how?
Do you pay attention to your own questions?
No, I do pay attention to my own question. But I guess the question I had was, do we know if it's even going to be visible to the naked eye? I guess this is what lots of people are interested in knowing, right?
Yeah, it's a comet of the century. It's like the third one.
Yeah.
Well, I mean, you just told me that we don't know how good our bright they're going to be. So how much do we know about that?
Well, I think that. Yeah. Go ahead, Max. I think you're well suited to comment on
that. I mean, there's two basic reasons for the hype. One, it's, as we talked about earlier, it's a fresh comet coming in from the Oort cloud, so a bunch of fresh volatiles that have never seen sunlight up close and personal like this.
Right.
And also, it's a sun-grazing comet, so it's a comet that, as you saw in that video, is getting very close to the sun. Not all comets get that close to the sun. Okay, so again, but we don't really know exactly the makeup of this comet or even the size of it, and things like that. So there's some variables in there. But those two components alone, the fact that it's on its first trip in, so it hasn't been worn down from previous trips near the sun, and the fact that it's going to get so close that it's a sun grazer, has expectations high. But how high, it's hard to say. And again, just to follow up on the point earlier about the being as bright as the full moon, that doesn't mean it will appear as big as the full moon. The nucleus. I mean,
otherwise it would be like the dinosaurs, right?
Yeah. So, and also I think in terms of hitting the Earth, as you saw from the video, it's not even that close. I mean, there's other comets and asteroids that have come much closer to the Earth than what you just saw, and so in passing through the trail, obviously is not really like a collision. That's just the particles left over in the trail. Just like every other meteor shower. In fact, there'll be one on August 11th and 12th is one of the typical annual meteor showers where we're passing through the trail left by a comet. And so again, that's not like colliding with the comet. That's very small particles debris left over from a comet.
Right.
Okay, while we're on this topic, I want to get to the YouTube comments. J7409 on YouTube goes, if it broke up when it's close to the sun, could a chunk of it hit Earth?
Well, breaking up is hard to do, but not for a comet.
Well, first of all, let me take a step back.
Not for a
how many think it's going to break up? Of the planetary scientists here, how many of you think it's going to break up?
That's a good question. I haven't been asked to take a position on that.
All right. I'm taking bets. I'll be the bookie on it. So.
I'll go out on a limb here and say it's going to break up.
Oh, okay. So there you go, folks.
Wow, I would have.
Bonnie, what do you think?
I want it to break up.
Oh.
I'll say that I want for that to happen. It'll be so exciting.
Okay, John Yang, your turn.
We'll get some great pictures too.
Yeah. I kind of agree with Bonnie. I think if it's gonna do something bad, or disappear or break up, then break up is better than disappear and be there.
Right. Yeah.
Okay. So that sort of appeals to our sense of action movies and death and destruction, right?
I have actually a question because so what are the variables that determine if it's going to break up or not? I mean, Max mentioned that it's a sun grazing, so it's a first time. So what are the how does the composition, for example, plays into all of this, right?
Yeah, I mean, there's two things. You know, you touched on it. The composition. How tightly or loosely assembled is it, right? And we know that a lot of comets are not tightly assembled. They may be kind of barely hanging together. It's certainly not like a chunk of iron that's really hanging together, right? It's a mixture of rock and ice. And then the other thing is when it gets really close to the sun, there's something called the Roche limit, where tidal forces, so any two gravitational bodies have tidal forces between them. And, you know, the tidal forces between the sun and the moon cause our tides. So it's kind of like how bodies are tugging on each other, right? They're kind of torquing on each other. And so as a comet gets really close, a very small comet gets really close to the gigantic sun, the sun is exerting gigantic tidal forces that are exerting different pressure, you know, different forces on each side of the comet and possibly ripping it apart.
Hold on, Max. I don't mean to interrupt you, but Zolt has to leave. Zolt, before you go, I just want to say thank you for the great work you did on the comet image that we produced on the blog. It's awesome work. Are there anything is there stuff coming up in the future we can look forward to from ISON and Hubble?
Well, unfortunately, Hubble can't look at the comet right now. It's we're behind this on the other side of the sun, and nobody else can see it either. But hopefully, when it's visible again to Hubble in the October time, we'll get some more images.
Get some more observations?
Yeah, get some more observations, and we should have some more images coming.
All right. Well, thank you, Zolt. I know you got to go. Thank you for taking the time out to join us.
No, this was
really
a great time. Thanks, everybody.
All right. Thank you.
Take care, Zolt.
I'm sorry, Max. I didn't mean to interrupt you like there. I just wanted to say goodbye to Zolt before he left.
That's okay. I was just finishing my point, but I'll just add to what Zolt was saying, is that there are quite a few programs approved. We have a few that have executed already. Jianyang Li is involved with, you know, he's leading one of them, and the Heritage team has several that are waiting for the comet to reappear in October and November. And obviously, if the comet breaks up or does anything else, there may be more proposals submitted to get even more orbits with Hubble to observe it.
Okay, we actually got a question early in the hangout about this, right? From Tony Burkhardt. Right. How much time has been given to Hubble to image Comet ISON? And so you want to give us your answer to that?
Yeah, I do have some notes. I mean, the coin of the realm for Hubble is orbits, and an orbit is about an hour and a half long. Although the whole orbit may not be usable. It may be something like 50 minutes or so within an orbit. And I'm looking at, I know there's, you know, there's, I guess, 4 different programs that have executed already, but not many orbits so far. I mean, each one being, you know, just a handful of orbits. I know for us, we've only used 2 orbits so far. And John Yang can tell you about his program, which executed in April. Going forward, there's at least 3 programs already approved. One is 12 orbits, another one is 12 orbits, another one is 19 orbits. Jianyang Li is involved in at least one of those, if not more. And then the Hubble Heritage team, we also have 4 more orbits to do observations similar to what we've already seen. And then we also have one in place to do what's called a target of opportunity in case the comet breaks up. Now, this is why I voted for the comet to break up. Because we do have a 5-orbit program to image the comet on the event that it starts to break up, because that's what Hubble could do best.
Okay, and Jianyang, you want to tell us a little bit about your program?
Yes, we had 3 Hubble orbits in April 10th to image the comet, and the main purpose of that observation was actually to measure the size of the nucleus, because, you know, everybody care about whether the comet's gonna survive the perihelion, it's gonna break up, or whatever it's gonna do. So and the size of the nucleus is actually the determining factor. So that's what we did with our observations. But unfortunately, it looks like the comet, the size of the nucleus is going to be very small. You know, we right now we have a very conservative upper limit of 2 kilometers, and it could be smaller.
2 kilometers, you said?
Yeah, 2 kilometers in radius. That's the upper limit. You know, that's not the size. That's the upper limit. So it's not going to be bigger than 2 kilometers in radius. And so it could also be much smaller. We don't know yet. We're still working on our data.
So you're saying that the size of the nucleus is related to whether or not it's going to break up?
Well, no. Actually, I'm sorry. That's one factor. I mean, if it's too small, it's going to be burnt up very soon, very quickly.
Right.
And that means it's going to disappear during perihelion passage. And whether it's going to break up, that's related to where to the closest point, to the distance of the closest point to the sun. And what I can tell you is that actually Comet ISON is going to pass the point where it's just the boundary of the region inside of which it's going to break up, and outside of which it's not going to break up. And then we know there's an uncertainty for this region, so that's why we say we don't know whether it's going to break up.
Okay, all right. So Scott, you have a question here in the chat. You want to go ahead?
Yeah, this is from Twitter. This is from @Cosmos4U. Looks like Daniel Fisher. Yep. And it says, for the NASA diagram, and I can put the link into the event page, it implies that radio observation of ISON are possible right now. Are those underway? Does anybody know?
Actually, I don't know.
I don't know much about it, but I think this is from when I talk to my friends who are working on radio astronomy, and I think it's right now it's probably still too thin for radio observations.
Okay, here's the
I was actually going to pull it up. You have it? Oh,
yeah,
okay.
here's the image you're talking about. So what are we looking at here? When will it be observable? And this is, oh, I see. And then there's different wavelengths at the bottom down here. There is a where it'll be visible in optical, and then a little bit higher up it'll be in radio. And it started, it looks like back in April or so.
Yeah.
So it looks like it should be observable now in radio waves, but yeah, I don't know the answer.
Yeah, that's exactly from one of my presentations, and this is originally made by my colleague Matthew Knight.
Oh, okay.
I see.
Oh, yeah, there's your name. You're right. You're right there on it. So explain this thing. Explain this graph.
Well, what this graph shows is that it's just the geometry, and we know that optical telescopes can't point too close to the sun, but radio telescope and IR telescopes can. So that's what we show here. The shaded area are when the comet is too close to the sun, so we cannot look at it with any optical telescopes, including Hubble. And radio can get very close to the sun, so that's why you see the continuous green arrows. So in that region, radio can look at it. But it's still limited by the brightness. The brighter it is in radio wavelength, the easier we can see it. Yeah. So I kind of doubt whether radio can see it now because it's still very faint. Okay. And then we have the IR, and then when it's very close to the sun and it's within the field of view of the solar telescopes, that's where solar telescopes are going to look at it. That's within the perihelion in late November.
Do you know if someone is going to do any LiDAR observations of it?
LiDAR, I mean...
What's LiDAR, Alberto? Mr. Jargon Master.
I forgot the acronym. Basically, we shine radio waves. It's like a radar, basically. We just shine radio waves. We wait for it to come back, and from the delay, we figure out the shape. For example, we do this with asteroids. We figure out their shape and their. So I don't know if you can do it on a comet. I mean, is it going to be close enough for us to do it?
So you have to do it when you are very close to the comet. So I don't think.
Okay, I see. I don't know. Okay, and then I'm going to figure out what LiDAR means actually.
I think it's with laser.
Yeah,
but sure, instead of radio, it goes with.
I forgot the acronym. So
it's an acronym within an acronym.
I know because laser is an acronym itself. So
yeah, I know. I love those.
I could be excused.
I heard you like acronyms. So I put acronyms in your acronyms.
Yeah, exactly. Recursive acronyms. Those are great. Oh, well, guys, we are out of time. I want to thank everybody for joining us. Dr. Meinke, thank you. Max, thank you for showing up. Dr. Lee, we really appreciated having you here. This has been great. We're going to have another one. Stay tuned for another Hubble Hangout. I don't know if it'll be the next one because we might do something in between, but there will be a Hubble Hangout coming up on getting your own Comet ISON data from the, is it MAST or HLA, Max?
MAST.
Okay, from the MAST archive. So the Mikulski
Archive for Space Telescopes.
Thank you, because it changed.
So many acronyms!
Yes, so Max will be on hand, I think, to help us sort through that and get some Hubble data for ourselves and be able to play with things. So look out for that. Also look out for my video on whether or not Comet ISON will hit us. That'll be coming out in the next 24 hours or so, and I'll be posting it to the HubbleSite channel, YouTube channel.
And I'll make a Vine version of it. 6 seconds. No.
That's right. Yeah. So it'll be real quick with Alberto going, no. So
with Grumpy Cat right next to him.
So thank you. So I want to thank you guys all for attending. Alberto, Scott, this has been, as always, it's been a lot of fun. Thank you for joining us. I really appreciate it. And we'll be back for another one very soon. So Hubble Huggers, stay tuned, and we'll see you soon. Thank you for watching. And as always, keep looking up. Hangout. We are here to talk about comets, and in particular Comet ISON. And I would like to introduce some planetary scientists we have with us today, two of which work at the Space Telescope Science Institute, and the other one at the Planetary Science Institute. So why don't we start with Bonnie Meinke. Hi, Bonnie.
Hi.
Hi. So why don't you introduce yourself? Tell us what you're doing.
Sure. I'm a planetary scientist, but I'm also a content specialist at the Space Telescope Science Institute in the Office of Public Outreach. And what I've mostly studied my whole career is Saturn, but I had one project back when I was an undergrad in college where I studied the possibility of interstellar comets. So
awesome.
That's my background in cometry.
And cometry. Oh, that's a great
cometry. Wow.
You
hashtag.
Yeah, cometry. I like that.
But we don't need trees on comets, right?
Okay, and also with me, Max Muchler also from the Space Telescope Science Institute. Max. Oh, you're muted.
It's muted.
Sorry, unmuted. So my name is Max Muchler. I'm a research and instrument scientist here at the Space Telescope Science Institute. I've actually been here working on the entire Hubble mission, 23 years. And I'm an expert on Hubble's cameras, so I really know how to design observations and reduce the data that comes out of it. And I also am a member of the Hubble Heritage team that is doing some of the observations of Comet ISON, the one that was released yesterday and one that was released earlier, and we have more observations coming up. So I've been involved with a lot of planetary science with the Hubble Space Telescope, earlier comet observations, including ones that have broken up, and observations of asteroids and dwarf planets like Ceres and Pluto. And so excited to be a part of this these Comet ISON observations, and look forward to a lot more coming forward.
Awesome. Yeah, well, welcome. That's good to have you here, Max. And also with us is Dr. Zhanyang Li from the Planetary Science Institute. Welcome. Can you why don't you introduce yourself?
Sure. Hello. Hi, Tony. Glad to be here.
Yeah.
And my name is Zhanyang Li, and I'm a research scientist at Planetary Science Institute. And I mostly work on almost all the solar system small bodies where we have data, of course. And I actually started as a cometary scientist at University of Maryland, and with Dr. Mike Ahern. And if you don't know the name, that's fine. But I think you must know the mission, Deep Impact mission. And Mike Ahern was.
Oh wow! Yeah.
Yeah. So that's how I started my work on comets.
Awesome.
And then right now I'm also working on asteroid missions. Like I also participated in Dawn mission as a science team member. And I also worked on the Dixie mission, which is the extended mission of Deep Impact, and also Stardust Next, which was the extended mission of Stardust mission. And and that's what I do right now. Yeah, I'm gonna talk more about Comet ISON.
Well, welcome. It's awesome to meet you. I'm looking forward to finding out more about comets from you. And also with us is Zolt LeVay. He's been on these Hangouts many times before with other things, but he is a imaging. He's the one that takes the images that Max has provided and turns them into amazing-looking images. Welcome, Zolt.
Thanks, everybody, and glad to see everybody here. Yeah, I'm in the Office of Public Outreach here, imaging group lead in the Office of Public Outreach, and I'm also the lead of the Hubble Heritage team. Max was talking about Hubble Heritage. And some of the observations that we'll be talking about were conducted for Hubble Heritage.
Okay, so before we get into the discussion too much, I want to start right off the bat by introducing, one of the reasons we're here is we want to introduce the ISON blog that we've started at the Institute on HubbleSite.org. I have it up on the page now. On the very top of the blog is an image that Zolt helped create, which we'll talk about more in this. but there are all kinds of posts on here all about not just Comet ISON, but comets in general. So we're hoping that you will subscribe to the RSS feed on this and see the posts. Some things that are imminent is I've got a video coming up on whether or not Comet ISON will actually hit us. That's going to go on the HubbleSite channel, YouTube channel, and we'll post it on this blog. So look for that in the next, hopefully the next day or so. But the URL for this is, unfortunately, I can't get my lower thirds to work because I'm doing this as the Google Plus page, and I had all kind of permission problems. So hopefully you can see the URL up there, but I will also be posting it on the event page. It's hubblesite.org/go/ISON, and that will get you there to check it out. So please subscribe to it. And is Dr. Alberto Conti. Hello, Alberto.
Hey, Tony. How are you? Nice to be here.
Yeah, thank you. He's the James Webb Space Telescope innovation scientist. So, Alberto, what's new with the Webb? Are we still on track for 2018?
We are on track for 2018. We're making quite a bit of progress in testing. We have 2 of the instruments at Goddard Space Flight Center that are being tested right now and waiting to be integrated. There's a lot of a lot of time is going to be spent into doing testing for the next few years. So it's a very exciting time, and so far we're doing very well. So nothing major to report, either negative or positive. We're just doing very, very well. We're on track. We're very excited, and we're working hard to make sure we stick to that deadline.
Awesome. I mean, they're building all that right down the road, aren't they, down at Goddard?
Yeah, it's just around the road. It's a few miles from here, a few kilometers if you're in the old country.
There you go.
Quick for the win.
Yeah. Well, good. I mean, 2018 can't come soon enough for me, so I can't wait. I'm glad to hear it. Okay, thanks for the update. And also, brand new addition, Scott Lewis from KnowTheCosmos.com. He is, you recognize him probably as the co-host for the Virtual Star Party with Fraser Cain. He also inexplicably goes with the Twitter handle, the Bald Astronomer. I'm not quite sure what that's about. It must be.
It's a long story. It's a very long story. Yeah.
Anyway, welcome, Scott. It's a real pleasure to have you with these Hangouts. I'm looking forward to working with you on these, and you're an awesome person in these things. So thanks for coming.
Hey, I've tried to emulate you as much as possible. I think it's working.
I find that almost always serves me well.
Yeah. You know, if you weren't so humble, you wouldn't be perfect. So.
All right. I'm getting fed just by listening.
Okay. So now, as you all know from the title of the. Hello, Hubble Huggers, and welcome to another Hubble Hangout. In this one, I'm really excited about this one because this is one of the first ones I've been doing. I'm actually doing this as the Hubble Space Telescope. It's funny because I don't feel like one. I don't feel any different. But you know, it says that I am the Hubble Space Telescope now, and so I'm here broadcasting as the Hubble Space Telescope. You also see me here, but as a member of the chat, but I've just got the Hubble Hangout banner on there. So let me just show you that because that's really awesome. That was done by Christine Godfrey here at the Institute, and I think it's an awesome graphic. So I just wanted to put that up there real quick. So before I get started with introductions, let me tell you how you can interact with the Hubble Space Telescope. That is me. What you do is you can comment on the Google Plus event page if you want to, and that's. You may be watching this event here. In fact, I should probably type refresh your browser on the event page. Also, you can leave comments on the YouTube channel if you happen to be on HubbleSite channel, where we are also broadcasting. You can leave your comments there. You can also tweet. Oh, we didn't do a hashtag.
Hubble Hangout.
Hubble Hangouts. That's awful long. You're going to use up a lot of your characters, but if you use a hashtag Hubble Hangout, we'll see that as well. So leave questions and comments. We'll have plenty of time for that, hopefully toward the end, where we'll try to get to all that, unless I see a particularly interesting one in the middle, and we'll just blurt it out somewhere along the line. We'll be able to do that. So, new format slightly. With me also, as he always